Okay, so we're going to talk about terminal arms today. Now, a terminal arm is anything where your angle off standard position. You have your initial arm still here on the x-axis, but then your other arm on your angle is on any one of the different here, here, here. Okay, so they run off of the axes. So angles of terminal arms is like 90 degrees, 180, 270, 360, and 360 also goes with 0, okay? Those are your terminal angles. So 90's here, 180. Oh, 270, 0, 360. Okay? Because you're still measuring off the x-axis any one of these points. Okay? So that's just a fancy term for more angles, okay? I don't really refer to it as a terminal arm, but the textbook does, so I thought we should just cover it. So what we want to do is we want to determine values of sine, cosine, and tangent when there's a terminal arm of a quadrant angle. And what we'll do is we'll look at 90 degrees. Okay, so we're going to examine sine of 90, cosine of 90, tangent of 90. Okay. Now, there is no special triangle for these ones, right? We don't have a 60-30 or a 45-45 triangle that we can use here. We just need to know kind of what we're looking at here. Okay? So, at this point here, regardless of what y is, we know what x is, right? X is going to be 0. And if we're solving for r, let's say we want r here, we know r squared equals x squared plus y squared. Our x value is 0, so we know that r squared equals y squared, so we know that r equals y. They're the same. And based just on that, we can solve for all these, regardless of whatever y is. It doesn't matter. It's always going to be the same. Okay? So for sine, we know it was, we talked about this yesterday, was y over r, right? Cosine is x over r. And then tangent is y over x. So now we know y and r are equal to one another, right? What's anything divided by itself?
1.
1. Right? Go ahead, hit sine 90 in your calculator. It should come up 1. He's checking. He doubts me.
Well, I don't doubt you. I just want to make sure I can do it.
Yeah, that's good. Okay. Cosine, that's going to be 0 over r. I don't care what r is. What's 0 divided by anything?
0.
0. So cosine of 90 is 0. And then tangent of 90, that's going to be whatever y is over 0. What's anything divided by 0?
Yeah.
Okay? So it doesn't exist. And there's your values for sine, cosine, and tangent at 90 degrees.
So those are your answers then?
Those are your answers. Now, I want you guys to try, if you have room on your sheet, this one. I don't have anything on the other side, do I? Perfect. I want you guys to try now. Sine of 180, cosine 180, and tangent of 180. Okay? So now 180 is over here. Whenever you're on the x-axis, you know that your y value is 0. And also, now that you're over here on teetering between quadrant 2 and quadrant 3, you have a negative x value.
So your tan's gonna be negative.
No. Tangent. Try, figure them out. Write them all out. Write this part out.
Y over r, x over r, y over x.
Okay, so now what's your y and x values?
It's negative x and 0.
Okay, so 0 over r. What's anything over 0?
0.
Right. Okay, now try the other two.
Sometimes negative x cosine.
Well, it's going to be negative x. Remember, for this one now, if y is 0, it's going to be r equals x for this one. Okay, so here. But r will be positive. X is going to be negative. Do you want me to go over?
Sure.
Okay, no problem. Okay, so let's quickly just solve these.
I just didn't get cosine, that's all.
That's okay, no problem. Basically, you just kind of switch everything around. It's always going to be one of these three things here. You just got to know where to put them.
Oh.
Okay? Like I said with these, we're going to, if we don't get to it today, tomorrow, we're going to figure out angles throughout this entire Cartesian plane. And you'll have a big, huge table, and it's basically going to be the same 5 or 6 numbers. You're just moving it around and changing signs on stuff, depending on what quadrant you're in. Okay? It's kind of cool. Now, okay, so sine 180. So we got y over r, so that's just going to be 0 over r. So it's 0. Okay? Cosine is x over r. Remember, x equals r here, but you're over here. Your x value is going to be negative, so it's going to be negative 1. All right, so if you put cosine 180 into your calculator, it's going to be negative, right? Because remember, another stupid trig class, cosine's negative between these two. Okay? There's another one I'll tell you guys later about that you'll definitely remember.
Inappropriate.
Borderline.
Okay.
And then this one here, y over x.
It's 0. There.
Actually, for tangent 180, you're going to have 0 over x. So tangent equals 0. Double check that.
That makes sense.
It seems right, right? I think I'm right. It's 0. See, so it's, you just kind of have to know how these work. So it's always going to be one of these values for your quadrants. 270, you're basically just switching signs. Everything's the same. And then 360 and 0 is the same, but you're switching signs again. Okay, just depending on what quadrant you're in. Okay, it changes your signs. Questions about term or quadrant angles? So 90, 180, 270, 360, or 0. Right on. Okay, let's move on then. So now what we want to do here for our next example is we want to solve for an angle given the exact value of sine, cosine, or tangent. Okay, so we want to find the angle now that we know the value of one of our trig ratios. So for our first one, A, basically what it's saying is you know that sine equals positive 1/2. And we're looking for any angle between 0 and 360. Okay? So, Now what you need to do is you need to remember your trig, your special triangles and your trig ratios. Did we take any notes on when sine equaled 1/2?
Yes.
Yes, we did, didn't we? For what value is sine equal to 1/2?
30.
Is it 30?
Yeah.
Okay, cool. So you
Yes.
know
Yes, that's right.
30 degrees, you know that the sine is opposite over hypotenuse. There's your 30 triangle, right? Or your 30-degree angle. So we know that sine equals 1/2. Our angle has to be 30 degrees. Now, this is saying for anywhere between 0 and 360. Is there another quadrant on our plane where sine is positive?
Not the second one.
Right, the second one. So, remember, your angle and your reference angle are the same.
Cool.
So if I have a reference angle here
30.
equals 30, that means sine is also going to equal 1/2. So if the reference angle is 30, my actual angle from there to there will be the same, right?
150.
Right. So if this is 30, this here has to be 150 degrees. Or 150. Is there anywhere else that sine's positive?
No.
No, just those two quadrants, so that's that. How does that kind of feel?
All right.
Good? Alright, let's try another one. Cosine is negative 3/2.
Cosine 0 to 30 degrees.
Good. 30 degrees. But cosine's positive here in quadrant 1. It's negative though in quadrant 2 and in quadrant 3, right?
What for? It's positive. It's quadrant 4.
Right, it'd be positive here. So we're looking for two angles in this guy and in this guy. We know that cosine 30 equals positive root 3/2. So now we'll just use our reference angles to find when it's negative. So one would be over here at 30 degrees. And the other one would be here if we drew a reference angle at 30 degrees. So we'll have one angle here. We're going to have one angle here. Where am I losing you?
Because in the second and third quadrant, they're negative.
Right, and look at our cosine value.
Oh, it's negative. Okay.
Yeah. Negative root
Okay,
3/2.
yeah. That's not that.
Question, Brooke? You don't think so? You're okay? Okay. Let me know. This is brand new. So just be aware of that. So I know that my two values for theta would be 150.
Yes.
Again, that just worked out like that. Normally it's not always going to be 150. Don't always write that down. And then it's going to be 180 plus 30 degrees, 210.
Alright, I just kind of got lost. I didn't see the takeaways.
No, that's okay. That's just one of those things you got to watch. Negative signs. Once you start learning about negative numbers in grade 5 or 6, they will haunt you through high school. It just happens. Okay? All right, last example, then I'm done yammering. Which is good because I've been talking for about 15 minutes now. Now this one, simpler, same idea, but this time you don't have to work with your triangles. Okay? For this guy here, we wanted to, given that cosine is negative 0.675, we want to find the angles again between 0 and 360. That'll give me the angle to determine it to the nearest degree, okay? Now, do we know anything on our 60, 30, or 45 triangles of when cosine is negative 0.6753? No, so we can't use that. We can't use our triangles. Go ahead, Emery. So now you just get to use your calculator. So all you need to do is just go cosine.
Negative 1.
Cosine theta equals 0.6753. So you're just going to find your angle using cosine negative 1. So you just punch that in.
47.5.
47.5 for the negative.
I got 132.
I didn't put it in there, that's why.
You got 132.4? Good.
I didn't get anything like that at all. That's 0.9993.
Did you put cosine negative 1 into your calculator or cosine?
Did that.
Yeah, you got to use the shift more, but, right? Because when you're finding the angle, you use this guy.
Yeah.
Okay. Okay, so there's the angle. Now, we need to remember though, I'm just going to draw it out like this. So that means we have an angle here, 130, somewhere like that. Now you don't have to draw this out every time. I like to just because it makes it easier to see. Now because my cosine value here is negative, that means I gotta look for the quadrants that cosine's negative in. So once again, quadrant 2 and quadrant 3. So what I need to figure out then is how far over into quadrant 3 is my angle. Dun, dun, dun.
Find the reference angle.
Yes. Is that what you were going to say? Yeah. Find your reference angle. What's this guy?
42.47. Whoa.
Let's go 40. Oh, no, that's not right.
It's opposite.
I'm recording this. You make me look like a fool.
No. It's to the other one, to the other angle.
Oh. Well, let's just see what our reference angle is here. So go 180 minus 132.4.
I said fine, that's fine.
47.6. There you go. Oh, you found the reference angle here. Gotcha. Okay. So that means our reference angle comes off of here, 47.6 degrees. So if you go 47.6 plus 180 now, your total angle from the origin here in blue, that's going to be 227.6. Now, if you remember from foundations, remember I said things like stuff like this and all that. Like negative, if you're using theta or negative theta, it'll give you the same thing. Remember we talked about that briefly? I said, you should know this, but you don't really need to know it, blah, blah, blah. This is kind of where that all comes from. Because sine will be positive in areas, and it'll be negative in other areas. Same with cosine and tangent. So depending on what you're working with, it kind of changes things, okay? Is this kind of making sense? A little bit? Okay, good. That's a good spot to be in. That means you just need to do some practice. Okay, any questions before I hit stop? Okay, I'm going to pause this now then.